Welcome back, ninth grade physical science. This is week number 6 of online learning. The focus of this week is we're going to be dealing with the concept of reflection. 2 videos are available for you to view this week. This video is filled with background information, a lot of important vocabulary terms dealing with this concept of reflection. Video number 2, we're going to build upon this information and we're going to focus on what happens when light rays are reflected off of mirrors. So for today, like I said, we're just going to focus on what is reflection. This presentation will go hand in hand with reflection notes that are available to you in Canvas. If you go to Canvas, you're going to find a Google document titled Reflection Notes. And as always, you can take that document, you can print it off, write on it, you can make a copy, you can type on that document. It doesn't matter. Either way, I just want you to know that that document is there for you to use, that you can fill in the information that we're going to be talking about this week with reflection. So getting started with reflection, I first want to do a little bit of review. I want to review a little bit on what electromagnetic waves are. First, electromagnetic waves are waves that are made by vibrating electric charges. These vibrating electric charges, because they're moving, are inducing a vibrating magnetic field. And it's when you have these moving magnetic and electric fields moving perpendicular to each other, always changing, that is what helps create the electromagnetic waves. And also remember that electromagnetic waves are waves that can travel in space. They can travel in a vacuum. They don't need matter present. Unlike mechanical waves that need matter, solid, liquid, gas, in order for them to travel through. And with electromagnetic waves, remember they're part of the spectrum. A variety of waves with varying frequencies, varying wavelengths, and you can see them on the screen in front of you. And what part of the electromagnetic spectrum do we see? That would be the visible part, light, which is the focus of that unit that we're on right now. On this screen, and also going hand in hand with your reflection notes, I want to give you a little bit information about the ray model of light. This ray model of light is a series of statements talking about what light rays can do. You see some on the screen. I've got 4 statements on your notes. There are many more, but I just want to focus on a couple of them, 4 of them in fact, and that's what you find on your reflection notes in front of you. So first of all, with this ray model of light, it states that light rays will travel in straight line paths. And how are light rays usually drawn? They're usually drawn as arrows. Also with the ray model of light, it states that those light rays, when they're traveling in straight line paths, they are traveling from some kind of light source. What is a light source? The sun, a light bulb. Light sources are classified as any object that is actually emitting the light rays. They are emitting that light energy. So not all objects are light sources. Another part of that ray model of light is it states that light rays will travel from a light source in all directions. And when those light rays, when they're traveling in all those multiple directions, it's when they actually meet at a single point, that's where you're going to have an image form. And later on in this video, we're going to talk about 2 types of images that form from light rays. But an image will form when those light rays, reflected or refracted, actually meet at that single point. Another part of that ray model of light, how do we get a shadow? A shadow will form when those light rays are blocked, and they have to be blocked by some kind of opaque or solid object. That's how you get a shadow form than when you're walking around outside. So again, that ray model of light, what you see on the screen, the statements that you have on your notes, they're just all statements describing what light rays can do. And like I said, there's many more, but I just wanted to focus on a couple of them. Another part of that ray model of light is it talks about 3 things that can happen to light rays when they leave a light source. We're going to focus on 2 of the 3 that you see on your notes. First of all, light rays can be reflected. That's where they bounce off of an object. So think of light rays bouncing off a mirror. The second thing that can happen to light rays when they leave a light source is they can be refracted, which means they actually are passing through an object, like a window, like a lens. The third thing that can happen to light rays when they leave a light source is they can be absorbed, absorption, where they're actually taken into an object. So think of wearing dark clothing on a warm summer day. So those are three things that can happen when light rays leave that light source. We, for today and for this week, are going to focus first on reflection. So when we talk about reflection again, what is it? That is when light rays bounce off of an object. Notice I added on this is that reflection does not include rays going through something. That's completely different. Reflection is when light rays bounce off of an object. Again, a mirror. And there are two types of reflection that we're going to focus on. One type is regular reflection. That occurs on smooth surfaces, and you can see the picture that I've got provided on the screen. When you have regular reflection, the light rays are reflected, are bounced off of an object at the same angle that it hits. There's a certain law that we're going to come to in this video called the law of reflection that focuses on this regular reflection. The second type of reflection is diffuse reflection. This occurs on rough surfaces. So again, take a look at that picture that I've provided. With diffuse reflection, that is where the light rays are scattered in many, many different directions after they bounce off the surface. But like I said, our focus is going to be with regular reflection, where light rays reflect at the same angle that they hit a surface. Okay, so moving on, I want to distinguish between two terms that a lot of science friends in previous years kept getting switched around. It seems pretty straightforward, but when we start using these two terms periodically, a lot of people have to stop and think, okay, wait, what are we talking about again? I want to distinguish first what's the difference between an object and an image. Because remember, I said an image is formed when you have reflected light rays meeting at a single point. But when I'm talking about an object, I'm talking about the actual source of the light ray. So for example, this could be you standing in front of the mirror. An image is classified as a copy of that object. And again, an image is formed by reflected, and we'll talk about next week, refracted light rays. So make sure you know the difference between those two terms, because objects, images, two completely different things. Objects are the source. Images are a copy of that light source. And when you have reflected or refracted light rays meeting at a single point, I told you get an image that can form. There are two types of images that we're going to talk about with reflection and next week with refraction. The first type of image that can form is called a real image. These images are true images, science friends. Real images made from reflected or refracted light rays that are actually meeting at a single point. How do you know if you're looking at a real image? You will know because these images will appear upside down. They're going to appear flipped. And because real images are made with real light rays, if we would pass our hand or block the light rays, we would form a shadow. So that's a good way to distinguish between real images and the next image that we're going to talk about. On this screen, I have a couple of examples of what a real image might look like. They are going to be upside down. They are going to be flipped. That's a telltale sign that you're looking at a real image. The second type of image we're going to talk about are virtual images. These are images that appear to exist to the human eye and brain. Virtual images are not formed, are not made by real, true light rays. They are not made with light rays meeting at a single point. How can you tell if you're looking at a virtual image? These images are going to be upright, and they might be reversed. And in a special situation with a special mirror that we're going to talk about later this week, a plane mirror, these are where sometimes these images can be life-size, where they are same size and same shape as the object. Classic example of a virtual image would be what you see in a bathroom mirror. In a mirror when you're looking at an image of yourself. They are upright, they are reversed, and in some cases they can be life-size, but that's not always going to be the case as we move forward. All right, the last concept we're going to talk about when we're talking about with reflection is we're going to talk about a certain law called the law of reflection. The law of reflection is huge, science friends, and it's going to be the focus of this diagram that you see in front of me. First, we got to know the parts when we're dealing with the law of reflection. So with the law of reflection, you need to know these important vocabulary terms in front of you. When we're dealing with the law of reflection, we are dealing with, first, we have to talk about incident rays. Incident rays or waves are the light rays that are actually striking the surface. After they strike the surface, those incident rays become a reflected ray. And this is light that is bounced off of the reflecting surface. You can also see on this diagram that we have a line called the normal line. This line is important. We need to have this when we're talking about the law of reflection. The normal line is a line that is drawn perpendicular to your reflecting surface. It is going to form right angles, and you can see that from the diagram. Also, when we're talking about the law of reflection, there are two angles of importance: angle of incidence and angle of reflection. The angle of incidence is classified as the angle between the incident ray and the normal line. And you can see that on the picture in front of you. The angle of reflection is the angle between the reflected ray and the normal line. Now, I said those two angles, angle of incidence and angle of reflection, are important because they are the basis of that law of reflection. The law of reflection states that light rays that strike a reflective surface, aka a mirror, are going to be reflected or bounced back at the same angle. So when we're talking about that law of reflection, our angle of incidence needs to equal the angle of reflection. And it's when those two angles are not equal to one another, that's where you get that diffuse reflection. Maybe you've got images that are forming that are a little distorted. They don't seem like they're an exact copy of the object that you're looking at. And this, science friend, is where I miss being in the classroom with you, because we have a fantastic lab that we do dealing with this law of reflection. And you actually determine, you measure the angle of incidence and the angle of reflection. And in years past, we always get almost exactly the same angle measurements. And that law of reflection, like I said, is important when we're dealing with regular reflection. And of course, it's important when we're dealing with mirrors, which is what we're going to talk about and be the focus of our second video for this week. So that is all that I have for just a background into what reflection is. What I will do is I will catch you on video number 2 for this week, where we're going to take reflection and we're going to look at mirrors.